Hi everyone, we're going to find the equation of the tangent and the normal of the curve y equals 1 divided by x minus 1. And this is at x equals 2. We're also going to draw our curve and the two lines together. The first thing we have to do is find the slope before we can find the equation of the tangent and normal line. We're going to use this formula here as a guideline. This is your slope. We don't have f, we have y. So I can set this up as the limit. I'm just going to rewrite this. H approaches 0. Instead of f, I'm going to put y, because that's what we have. Y, our x is 2. So we're going to write 2 plus h minus y of 2 divided by h. That's our formula. Now this is our y, so you're going to write this equals the limit as h approaches 0, and then you're going to have 1 divided by your x. So your x is this part here. So that's going to be 2 plus h, and we still have this minus 1. Minus 1 divided by, substitute in your 2 minus 1. All right. And this is all divided by h. All right, let's see. If you simplify, we're going to get this 2 and 1. So let's simplify this. Limit as h approaches 0. So this is going to end up being h plus 1. And this is going to simplify to minus 1 divided by h. Now let's get our common denominator. So I want this to also have h plus 1. So I have to multiply this by h plus 1. Like that. So that's going to give you the limit as h approaches 0. And our common denominator is h plus 1. And then we're going to have 1 minus h plus 1. And we're dividing by h, but I can move this h up here. So I'm going to move this h up here. So this is going to give you the limit as h approaches 0. And the 1's cancel, so we're going to have, let's see, negative h divided by h times h plus 1. All right. So since these cancel, this is going to give you the limit as h approaches 0 of negative 1 divided by h plus 1. When you substitute in your 0 here into this 0 here, this is going to give you the limit. It's going to equal the negative 1. So your slope is negative 1. All right, now let's get our equation of the tangent. So our slope equals negative 1, and it passes through x, comma, and let's just put y of 2. So that's going to be 2, comma, y of 2 is going to be 1. So it passes through this point. So this is going to be our tangent. So y equals, let's put the y minus 1. We're using point slope form, equals negative 1 times x minus 2. This is going to give me y equals negative x plus 2, and you add the 1 to both sides. This means it's going to be y equals negative x plus 3. So that's the equation of the tangent, where our slope was the tangent. Now for the normal, that's the negative reciprocal. That's just going to be 1. So you do the same thing, right? Y minus 1 equals, but your slope is 1 now. X minus 2. That's going to give you y equals x minus 2 plus 1. And that means you're going to get y equals x minus 1. All right. Now let's graph all this together. I went ahead and sketched the graph here. It's really hard to graph on here, so Basically, this is a rational. 1 divided by x is your parent function, and you have a horizontal asymptote here at x equals, or vertical asymptote at x equals 0. This is a shift to the right by 1, so I just shifted my asymptote over by 1, and then I just graphed the parent function over by 1. Now let's graph our lines. We had the tangent one, let's do this one in red, was, what was that? Y equals negative x plus 3. So plus 3, 1, 2, 3. And you're going down 1 over 1, down 1 over 1. So it's going to hit here, at this point here. That's the tangent. And what was the normal? The normal was y, let me write normal, was y equals x minus 1. So that's where you start here, go up 1 over 1, up, so it hits here as well. So there's your normal, right through there. Your normal's perpendicular to the tangent. And that's it. Thank you. Have a nice day. Bye-bye.